The following slides of this video tackles the fundamental concept of inductive sensors.
1958. This was the year in which the modern contact lenses and hula hoop were invented, but they were not the only innovations that year. Exactly 60 years ago in Mannheim, the inductive proximity sensor was born, and it would prove to be a groundbreaking invention for the world of automation. Few electronic components have such a long history in automation industry. The inductive proximity sensor has been in use for such a long time that it is hard to imagine the industry without it. These sensors set new standards for reliable non-contact, wear-free detection of metallic objects. No such thing as can't. This was Gale's famous mantra. True to his motto, the ambitious engineer working together with Walter Properl succeeded in evaluating the damping of an oscillating circuit using a bipolar transistor and converting it into a switching signal. The innovation was known as Cortex system for non-contact switching in explosion hazardous areas and formed the starting point for the inductive proximity sensor that is today a firm fixture in industrial applications. The world's first inductive proximity sensor was created just a year later in 1958 in response to the need for a robust component that would still function reliably after thousands of switching cycles, yet had a low enough power requirement that it could be used in explosion hazardous areas.
What is inductive sensor? An inductive sensor is an electronic device that can detect ferrous metal targets without physical contact. Inductive sensors will also detect non-ferrous metal targets like aluminum, brass, and copper, but using non-ferrous metal targets decreases an inductive sensor sensing range.
Robust devices and an essential component used in machines, designed depending on the requirement of proximity sensor, capable of detecting conductive otherwise metallic parts where contact is difficult, used in hygiene-based and outdoor applications.
The sensing range of an inductive sensor is the distance from the sensor's face to the maximum distance the sensor can detect a metal target. This implies that the inductive sensor has a sensing range that can detect metal targets depending on the type of metal that should be detected or the amount of iron that is present in a ferrous metal.
If the object is a non-ferrous metal, meaning it doesn't have a significant amount of iron within it, you need to consider a simple correction factor when defining the sensing distance.
What is the working principle of inductive sensor? The working principle of an inductive sensor mainly depends on the electromagnetic induction principle for detecting or measuring objects. Inductive sensor mainly includes an induction loop, which is enough for detecting electromagnetic. The working of the sensors can be done by generating an oscillating electromagnetic field which is formed by a magnetic object when it is in motion. The moving object activates the current flow within the induction loop, likewise with Faraday's law of induction, so that changes will have occurred within the electromagnetic field, so it can be detected with a circuit of sensors. A suitable signal can be an output when a magnetic metal is noticed.
We have four major external parts of an inductive sensor, which are the body of the sensor, the sensor's face, the indicator light, and the cable end or cable connector end.
The inductive sensor can either have a connector, cable screws onto, or have a cable with three different colored wires on it such as brown, blue, and black. The internal parts of sensor body is composed of oscillator and current sensor that makes the sensor work. The face is capable of detecting the target. As the target is within the sensor sensing range, the indicator light turns on, which is located near the cable that is connected with the sensor.
Sensor's body constitute the circuitry that makes the sensor work is located. The face is the part of the sensor that detects the target, while the indicator light is usually near where the cable gets connected to the sensor and turns on when the target is within the sensor's sensing range. Sensor's cable has three different colored wires in it: brown, blue, and black. These sensors are available with a cable that is already attached, or they can have a connector that the cable screwed on it.
The four main components of inductive sensors are the following: the coil, oscillator, Schmitt trigger, and output switching circuit.
Shielded and unshielded versions of inductive sensors. In shielded inductive sensor, the surface of the detective coil or shielded proximity sensor is covered with metal, so the electromagnetic field is concentrated at the front of the sensor, while in unshielded inductive sensors, the electromagnetic field generated by the coil is not restricted and has longer and larger sensing ranges.
The inductive proximity sensors are categorized in 8 categories based on application. First is the high-pressure proximity sensor. Pressure-resistant proximity switches are a type of sensor that used in situations where there is high pressure and can withstand pressure. In the manufacturing of high-pressure proximity sensor, rugged stainless steel is used, and the housing is extremely resistant against pressure and is full metal. This sensor can be found in special demanding applications. Next is high-temperature proximity sensor. High-temperature proximity sensors are specialized for applications that extremely high temperatures are involved in the application, such as industrial furnaces, combustion chambers, metallurgical processing apparatuses, and glass industries that are temperature-dependent systems that require constant thermal monitoring to maintain optimal working conditions. These sensors are designed for use in situations that temperature is rated up to 180 degrees Celsius. Some of the more common techniques used to reach the rating are special mechanical construction, select electronic components, replacing the standard housing material PTB with temperature-resistant material.
Another type of inductive sensor is rectangular proximity sensor. Rectangular housing are space-saving flat housing sensors used in application where there are space limitations and cannot use standard cylindrical because there is not enough space. There are two types of rectangular sensor. In one type, sensing phase is placed on small side so the height of the sensor must be considered, and in the other type, sensing phase is placed on the larger side so the length of the sensor should be taken into account. Analog proximity sensor. Analog output proximity sensors produce a continuous current signal or voltage signal that measures the distance of the target object from the sensing device. They also feature an outmost linear output voltage. When choosing an analog output sensor, your choice generally comes down to analog voltage 0 to 10 volts or analog current 4 to 20 milliampere.
Next is high protection proximity sensor. High protection class inductive sensors are sensors that are resistant in all conditions and work in harsh environments and are currently in use in virtually all industries. Maritime inductive sensors and washdown inductive sensors can be used in the manufacturing of these sensors. Maritime sensors are impervious and also corrosion-proof and resistant in salt water, while washdown sensors are designed especially for the most demanding cleaning processes required in food and beverage applications. Next is the full metal proximity sensor. Full metal stainless steel housing is highly impact resistant, resistant to chemicals, corrosion and deformation, and also waterproof during high pressure cleaning. They are ideal for use in following industries such as food and pharmaceutical, beverage manufacturing, metalworking, and chemicals.
And lastly, weld immune proximity sensor. Weld immune sensors are used in welding areas that are capable of withstanding high-intensity magnetic fields as well as welding sparks and slugs. Magnetic field immune electronics, welding sparks and weld slag resistant body, high temperature resistance, and sensing phase are some of the features of this product.
The advantages of induction proximity sensors are the following: detection without any touching, reliable function in harsh environment, long service life because there is no moving part, simple structure and cheap in price, high measurement accuracy, and high sensing rate.
The disadvantages of inductive proximity sensors are limited detection range, sense only metallic objects, and high temperatures, cutting fluids, or chemicals can affect the operation of the sensor.
It is undeniable that the design, flexibility, and exceptional performance of inductive sensors make them an ideal fit for a wide range of various applications and industries. It is used in industrial machinery, motion position detection and motion control and mechanical motion detection, production of coils and transformers, in traffic lights and traffic control and metal detectors, automatic car washes, detection of elevator door closure. In the industrial sector, the inductive sensor is used in counting parts system, separation of parts with different dimensions.
And that would be all. Thank you.